We do have a small part in that second part, right? So we'll discuss that first and then we'll go for the next question, okay?
Okay, sir.
That is the eighth question. Under forces and shape, the lesson that we have done in the last class. The drawing below shows a car pulling a car. They are traveling at constant velocity, right? So there's an object. Just imagine two objects are there. One object is pulling the other object. Same. Copy the drawing. You don't want to draw the same part. You can just take it as a circle and a box or something else, just to show you that two objects are there. Label the forces that are acting on the caravan with arrows, showing the direction that they act in. Right. So you have to apply the forces. Actually, how to show the forces acting on the object. Label the forces that act on the car as well. What do you think? What are the forces acting on the object and acting on the car? Can you tell me?
Applied force.
Applied force. What else?
Frictional force. In that, dynamic force. Dynamic friction.
Dynamic friction. Actually, the dynamic friction is what straight away we are taking as the friction. What else is there?
Unbalanced force.
Unbalanced force. Okay. Let's have a look like this. If I say this is the first object and it is connected with the second object. Okay. Second object there. So this object is pulling, right? And the question is saying it is pulling the second part. Second part is also moving on. So when you come for this part, forward will be the driving force. It is the driving force. The unbalanced force is moving on. Okay. Or else the force applied, we can say, right? Because there's a friction also. So the friction will be there in the opposite direction here, between the force, between the contacting surfaces, correct? This is the friction here. This is the friction. Okay. So when you come for the car, the first object, there is a friction. There is a friction. And the second object, when you're going to take, okay, the second object, when you're going to apply here, okay, now you see, these two are collectively connected, right? It is simply two words are being used up here. Okay, two words are being used up here. So as an object, collectively, when we are taking a circle, is pulling a rectangle. Okay, so this is the ultimate force acting. This is the ultimate force acting on the diagram. Okay, so the same force that you are applying here after the friction, okay, that is not acting on this object, but there is another friction as well. There is a friction between these contacting surfaces as well. Okay, so you see two frictions are there in between the tires of the car, the first object, and the road, and the caravan and the road, the second object. So both the friction are acting in opposite direction while the driving force is going forward. Driving force is going forward. So ultimately, what is the driving force you are giving? That is the same driving force applied here as well. Applied here as well. Now let's say if I am going to mark here also another force. Okay. Just because of the second object is also being pulled up. Just because of the second object is also being pulled up. If I am marking the same driving force here, for an example, let's say this is 10 Newton. Then I'm marking again here 10 Newton means 10 plus 10 becomes 20, which is not correct. Which is not correct. Yeah, we are discussing that 8th question. Okay. So only once I'm going to mark the driving force. So simply remember, take like this. Just imagine now it is a car and a caravan, so it seems to be two objects. Imagine of something like this. It is a browser or something, or else a container, a lorry, a long lorry. So there would be a startup material. The object here it is. This is the front part, the front space. Back of the part is a long distance, or as a train. Imagine. So train, every block we don't mark the driving force, right? 10 blocks are there. Let's say in the train, we don't mark the force in every one. Okay. What is the driving force? That the driving force is what given at the very first block where the engine is. So that will be the driving force. As it is connected one after the other, the same driving force is what is applied to pull the object. So the driving force given by the car, only here we mark, we don't want to mark here. We don't want to mark here. If I'm going to mark it there, it is something like, example, 500 Newton applied at the front space of, for an example, okay. Practically it is not correct. 500 just I'm taking. In the front block, every block if you are going to mark 500, 500, 500, 10 blocks means 5,000 it comes, which is 10 times of the exact force. So we don't mark like that, only at the front. But the friction will be there between each of them because all of them are being contracting, right? So these are the two forces horizontally we are marked. And the question is saying, copy the drawing, label the forces that are acting on the caravan with arrows showing the direction that they are acting. Okay. So since it is speaking about the car pulling a caravan, so I'm taking on one direction only. Okay. And also they are moving at the constant velocity. That means no unbalanced force, it is balancing up, it's moving on. So moreover, vertically when you're gonna take, the weight will be there down, reaction force will be there up. And again here, the weight will be there down, reaction force will be there up. Is that clear? So those two forces also we can mark if we consider the total, the whole acting forces. Okay. So let me mark that as well. The upward force will be the reaction force here. And the downward force will be the weight. And here also, it is the weight of the second object. This is the reaction of the second object. And that is an alternative part. Additionally, I am giving you, right? That is the 8 questions answer. Got it? 8 questions answers are what we wrote. Okay. Driving force and friction, they are what the main part here. And there is another question also, no, label the forces that act on the car. So both together we have done. Hope you are done. And what is the next question? Next question, it is a graph question. I hope you should have done that. Let me just remind you how to do it. Look at the first part. Can you say the information in the following table was obtained from an experiment with a spring of original unstretched length 5 centimeters. That means unstretched, the real length is 5 centimeters. So the load is given and the length of the spring being extended. It is also given. And you have to find out the extension first. Copy and complete the table by calculating the extension. So how do you find out the extension? From the real length, the original length, how much it is increased. You have to take the difference. In the first case, there is no extension, right? In the first case, same 5 centimeters are there and moreover, there is no load applied. So it is 0. And the second one, how much it is increased? 0.8 centimeters increase. So the extension is 0.8. The third one, 1.5. 1.5. And the fourth one, 7.4 means 2.4. And then 3.3, 4.7, 7.9. Likewise, it is increased. That is the extension. How much increased from the real level? Then it is asking you, use your table to plot a graph of force against extension. So what are you supposed to do here? You have to plot the graph. You have to plot the graph. So how do you take? You have to take the load in one side, okay, and the extension you have to take in the other side. So 2 axes you have to take. So taking both the axes, you have to plot them. Okay. So if you're gonna take the spring load 2, 4, 6, 8 multiples of 2 are given starting from 0, you have to take equal. And the other side, only the extension you have to mark. Okay, the extension is what you are marking, not the total length you mark there. 0.8. Okay, so it is giving you 0.8, 1.5, 2.4. Likewise, it is giving on, right? So which is a common, which is a very friendly scale will be there, right, among all the differences. So you have to find out that scale and you have to do. You have to draw it. Okay. So what do? You have to complete this question, take a photo and forward it after the class. Okay. After the class, if you have already done that, take a complete photo of your answer, a picture, clear picture of your answer, and better if you can convert it into PDF and forward me. Is that clear? And for my number, okay, not for the institute number, to my number, please forward it. Okay, I'll just check it through how you have done, how you have completed the graph, plotted the graph. Okay, and then if there are any errors, I will instruct you. Okay, fine. Let's get into the next point, the topic today. So what is the topic today? What is the topic today? I have sent you the topic, right? What is the topic today? Forces and movement. Forces and movement. It's the topic today. All right. And it is the third point in the unit 9. Sorry, unit 1. Unit 1. In unit 1, third sector. So first one we discussed about forces and motion. Second one, sorry, movement and position. First one, forces and motion is our unit name. First part, movement and position. Second part, forces and shape. And the third part, forces and movement we are going to discuss. Here we are going to speak about the laws related to movement. Okay, fine. So related to these laws, there are some rules and regulations given. And we have already learned about what is a force, what is a motion, everything about the unbalanced force, the forces applied, contact forces. So all these things we have learned. Okay. Now, three laws are there. Three laws are there. Three principal laws are there given by Sir Isaac Newton regarding these forces. Regarding these forces. So what are the three laws? We simply term them as Newton's three laws. Newton's three laws. Okay. So what are the Newton's three laws? First one, the first law says that until an unbalanced force is acting on an object at rest remains stationary, while an object in motion moves at uniform velocity. We already learned about the unbalanced force, right? Can you remember? Okay. You are applying a force, just because of you apply a force, the object is not moving because an opposing contracting force is there. Maybe a friction, drag, air resistance, whatever. So you have to overcome that. It depends on the media, right? You have to overcome that. So more than the maximum opposing force, what is the excess of the force you are giving? This is what we termed as unbalanced force, the resultant force. So related to this unbalanced force, only the laws are given. The force laws are given, motion laws are given. So here you see, first law says that until an unbalanced force is acting on it, an object at rest remains stationary. Now let's say an object's there. This is the object. This object, it is at rest. It's already at rest. You are giving a force. You are giving a force. But there is no unbalanced force. Okay. So here, let me take it as UF, unbalanced force. There is no unbalanced force. Unbalanced force is 0. That means you might be applying a force which is less than the unbalanced force. Okay. Maximum force that you have to apply is 100 Newton, let's say. More than 100 Newton, if you are applying only, the object will be moving, let's say. That is unbalanced. If you apply a force less than 100, that is not unbalanced. That is not unbalanced. So you see, unbalanced force is 0. So that is an object at rest. Another object I am taking, it's already moving. It's having a velocity. Okay. Already moving. And here also, you might be applying a force, but it is not unbalanced. So unbalanced force is 0. Resultant force is 0. So unbalanced force 0, resultant force 0. In these two cases, the first law says that, okay, the first law of Newton says that if there is no unbalanced force, there is no change in motion. Because already we learned there are 5 instances of 5 changes given by applying an unbalanced force. Can you remember the first class we learned? By applying a force, an object at rest, you can move it. An object in motion, you can stop. The speed of an object you can change, either increasing the speed or decreasing the speed. Acceleration, deceleration. The direction of the object you can change. Okay. And the shape of the object you can change. What are the 5? Object at rest you can move. Object in motion you can stop. Speed you can change. Direction you can change. Shape you can change. So always remember, when the answers are given, if any of the answers are lying among these 5 factors, that means there is an unbalanced force. If there is no unbalanced force, none of them will be there. None of them will be. So here, no unbalanced force means at rest cannot be moved. So what happens here? What happens here? This remains rest. An object at rest remains rest. An object in motion, already it is moving, moves at constant speed, constant velocity. So you see, you don't apply an unbalanced force, object remains rest. At rest, remains rest. An object in motion, already it's moving. You're not giving a force to either increase or decrease the speed, so it moves at the same speed. This is the first law. This is the first law. So from this, we are deriving some ideas. That means, let's say if there is no unbalanced force, okay? If no unbalanced force acting, if there is no unbalanced force acting, that means UF, I'll just take it as this is not a standard symbol, just I'm taking short. UF is equal to 0. Unbalanced force is 0. Unbalanced force 0 means for the acceleration is 0. There is no acceleration. There is no acceleration, there is no deceleration. Plus minus both are not there. It's 0. If the unbalanced force is 0, acceleration is 0, what is the idea from here we are deriving? Either the object should be at rest or it should be moving at constant speed. Okay. So then, if no unbalanced force acting, unbalanced force is 0, that means acceleration 0. Hence, object is either at rest or moving at constant speed. So this is the idea we are deriving from this. Is that clear? Clear? If there is no unbalanced force, this is not acting. Okay. Reverse of this theory. This is forward, let's say, this is the reversed idea. Okay. Again, see, unbalanced force 0 means remains rest, moves constant velocity. So that is the idea we are obtaining from this. So this is the first law. This is the first law. Very easy law. Okay. So shall we write them? Actually, related to the first law, as a law, it is not given on your textbook. As a law, it is not given on your textbook. But when you are learning about the forces and the movement, the motion, definitely you must know about it. So I'm giving you the note along with. Okay. So let's write there. Put the topic forces and movement. Sector number 3, forces and movement. And put the subtopic there. Newton's laws of motion. Newton's laws of motion. Newton's laws of motion. And write there the first law. Okay, let's write there. You can note it down. Until an unbalanced force is acting on it, until an unbalanced force is acting on it. An object at rest remains stationary. An object, by the way you are writing, take the words. Okay, that's very easy to remember as well. Okay, that's not so hard, right? Until an unbalanced force is acting, an object at rest remains rest. An object in motion moves at same velocity. Okay, same speed. Write it down. Easy, you can remember. And then we'll note this down. Finish writing. Okay. Note it down, please.
Sir, still writing. Okay, sir.
Below the row, you can write this down. Okay, you can use some colors, different colors you can use to just highlight the points. Okay. Are you done? Very excellent.
Okay, sir.
Sharon, are you done? Shall I go to the next one?
Okay, sir.
Right. So this is about the first law. And the second law. What does the second law says? Now, an object. This is what the main law here. In fact, mainly on your lesson, this is what target. Okay. Second law speaks like this. An object, it's having a mass n. It's having a mass n. Okay. An object is there. It does have a mass n. And you're going to apply a force F on it. You are applying an unbalanced force. You are applying an unbalanced force. Because of this force, it is increasing the velocity. So there is an acceleration to the same direction. There is an acceleration to the same direction. So the second law says that, okay, it is building up a relationship between these three factors. Now, you know, force is simply a pull or a push. Force is simply a pull or a push. It may be a pulling or a pushing. Okay, whatever. It should be an unbalanced force so that the object will be moving. If it is an unbalanced force, then only the object will be either being pulled or pushed. Right? That is force. Acceleration is due to the force you are applying on increasing the speed. If the speed is increased, that is acceleration. Positive acceleration. Negative deceleration. If the speed is decreased, that is called deceleration. That is called deceleration. Right? Then what about mass? M. What do you mean by mass? Mass refers to, is a theory, okay? Mass refers to amount of matter. Amount of matter in an object. Let's take this marker. Okay, this marker is made up of some matter. How much matter it contains? How much matter it contains, that is its mass. And this mass is what we measure in kilograms. We measure the mass in kilograms. Okay, so mass to weight, there's a clear difference. That is also a theory. We have to take it a bit later. Okay, so at the moment now, mass is the amount of matter. Force is, okay, the pull or a push you are applying on an object. Due to the force, what is the change in speed, change in velocity, the rate of change of velocity, that is called acceleration. So related to them, there is a relationship built up by the second law. Second law says that the acceleration acting on an object due to the motion, due to the unbalanced force, is directly proportional to the force. What is the force you are applying? To the force, acceleration is directly proportional. There are two proportionalities, right? One is direct proportion, the other one is inverse proportion. Direct proportion refers to you increase the force, acceleration increases. You decrease the force, acceleration decreases. That is direct proportion. Inverse proportion. What is inverse proportion? You increase one quantity, the other one will be decreasing. That inverse proportion goes with another two factors. Okay, what is? Acceleration is inversely proportional to or directly proportional to 1 over n. This is direct proportion alpha. This is alpha. The symbol is called alpha. It is direct proportion. So A is directly proportional to 1 over m. 1 over m means one down the other. That means it's having an inverse proportion, up and down proportion. Up and down proportion means one is increasing, the other one decreases. The meaning of that is when the force is increased, acceleration increases. But at that time, mass must be kept constant. Mass must be kept constant. So when you are concerning three factors, one should be constant to speak about the other, compare the other. So in this case, mass must be constant. Okay. So here the mass is constant, so these two are direct proportional. And here the force is constant. You are giving the same force. You are giving the same force. When the force is constant, these two are the inverse proportion. You increase the mass, acceleration decreases. You decrease the mass, acceleration increases. Acceleration increases. So these are the two relationships built up. And this can be written even in this way. Like acceleration is 1 over alpha m. This way also you can write. Either alpha 1 over m or else 1 over alpha m. 1 over alpha m. So both of them are inverse proportion. Okay, inverse proportion. Now, hope this part is clear, right? What is the theory then? Second law says that acceleration acting on an object is directly proportional to the unbalanced force acting, while it is inversely proportional to the mass of the object. So, Using this, a relationship also we are building now. Okay, first let's have a look. Let's write the second law there. Newton's second law. The acceleration of an object is directly proportional to the force acting on it, while it is inversely proportional for its mass. Let's write that down on the screen. Once you are done with that, you can copy this down. Okay, let's take this note. Right. So let's have a look now. You can see Newton's second law. What is the law? Acceleration is directly proportional to the unbalanced force, while it is inversely proportional to the mass. Right? And I told you, inverse proportion means when the mass will increase, acceleration decreases. Look at this. Can you see here? The first example. You can see two balls are shown. One is a bigger one, the other one is a smaller one. Okay. So it indicates that this is having a heavier mass, the larger mass. Okay. And this relatively having a smaller mass. So I told you, when we are concerning these three factors and you compare two factors, the third factor must be constant. So here, this happens when mass is constant. If m is constant, the box bracket shows you constant, not changing. So can you see here, the first case, it's actually going up with the force and acceleration. Force and acceleration, right? And you can see, when the small force is applied to objects with different masses, the smaller mass will experience a greater acceleration. Okay, greater acceleration. And look at the next one. Look at the next one. I'm going to speak about the second part of the image. Can you see there? Mass is same. Can you see? Can you observe it? Both of them are having the same mass. Can you see? Mass given just capital M. It shows you that the same mass is there in the second part of the image. Okay. And you can see the first one is showing you relatively a long arrowhead is showing. And can you remember we spoke about that? The arrowhead, the length of the arrowhead indicates the value of the force, magnitude of the force. More the length, bigger the force is. So here it's a longer length, so it's a big force. Second one shows you a smaller force. Okay, a shorter length, smaller force. According to this, what it should be happening? If okay, force is increasing, acceleration must be increased. If the force is decreasing, acceleration must be decreased. Acceleration must be decreased. Correct? Correct? So there you can see two objects are there. Two objects are there. First one is having a big force and should be a larger acceleration. Second one is having a smaller force, so should be having a smaller acceleration. Okay? This is what indicated by the second image here. Second image. Okay. So let me take that two objects are there having the same mass, capital M, right? Here you are applying a larger force. Let me say I mark it as F1 here and A1. And here I'm showing F2 and this is A2. Okay. So I'm saying here F1 is more than F2. You can see F1 is longer, F2 is less, right? Shorter, right? So F1 is longer than F2. It is indicating you F1 is more here. So as F1 is more here, acceleration 1 should be more than acceleration. Correct? Acceleration 1 should be more than acceleration. Is that clear? So this goes up with the first part. Acceleration is directly proportional to force. Acceleration is directly proportional to force. Okay. Same way, if I'm going to take the second part, there what should be happening? Force must be same. Force must be same. So let's say, let me take this part here. If F is constant, if F is constant, what is the theory here? Acceleration is inversely proportional to mass and inversely proportional to mass. What is the idea of that? Now here, mass you increase, acceleration decreases. Mass you decrease, acceleration increases. That is the idea of that. Correct? That is the idea, right? Why is that? Because inverse proportion now, right? Inverse proportion means when one is increasing, the other one should be decreasing. So mass is increasing means acceleration decreases. Mass is decreasing, acceleration increases. In both the cases, force should be same. Force should be same. So you can see here, look at the first part of the image now. Can you see in the first one? Mass is high. Second one, mass is relatively low. So you are giving the same force. Two objects are there. One is a pumpkin, the other one is a tomato, imagine. Both we are applying the same force. We assume that both of them are having the same density. Okay. Who will be running faster? Is it the pumpkin or the tomato? Tomato will be running faster, right? Because it's having a smaller mass and you are giving a force there. And the same force when you apply on the pumpkin, which is heavier, larger, that would be slowly moving on. So it would be having a slow, smaller acceleration. So the accelerations are different over there. Okay. So accordingly, you see here what we do, we're gonna take two objects. One is having I'll mark it as M1, and the other one is M2. Okay. So you are going to apply a force here. Same force you are applying. And the acceleration you are going to speak about. Acceleration you are going to speak about A1 and A2. What would be happening? Let me mark. I'll take the point here. If M1 is less than M2, you can see this is a bit smaller, this is a bit large. M1 is less than M2, then A1 should be more than A2. M1 less means A1 should be more. Am I correct? M1 less means A1 should be more. Correct? Right? So you can see M1 is smaller, M2 is larger. So accelerations are given as A1, A2. Mass less means acceleration should be high. Mass more means acceleration should be low. So this is the theory we are deriving from the second part of the flow. Acceleration is inversely proportional to mass. Acceleration is inversely proportional to mass. Did you understand? Is that point clear? Of the points clear, right? Okay. Shall I note
Yes,
it down
sir.
quickly? Yes.
Okay.
We'll note it down. You have already written them. Just below them, you can write those parts. And you can draw these diagrams I'm giving you to compare easier. Because we have written already the note. We are writing short notes. Short notes are showing you the idea as a picture. Please note it down. And meanwhile, when you are writing, when you are taking the notes, if you got any questions, any doubts, so how it happens and all, you may ask, okay?
So are there relevant equations for each law?
Yes, we are in the process of building it up. After this, we will be coming to the equation. So using these theories, we are building up an equation, one of the major equation in physics.
Okay.
Hope you are done. Right. So now, using these theories, we are going to build up the equation. Okay. Look at this now. And just before that, a small activity out of what we have learned. Now you can see what we do here. We do have a trolley and we have kept this trolley over a sloped surface, an inclined surface. Okay. So in this inclined surface, you can see there's a trolley, and over the trolley, I do have some sort of blocks or any sort of objects. So to add up with the mass, all right. And a nylon line is there adding up with to pull it over around a pulley, and here I do have a mass hand. I'm having a mass hand. So initially I do have one object over there, right? One block is there. So I'm going to check it with what happens when I increase the weight at this mass hand. So on the mass hand, I do have a sort of weight, so that the weight is applied. That is the gravitational force here. So it's going up with the second law. When there is a force applied, you increase the force. What is happening for the acceleration? You are going to check. And what I do, so you can see here, I'm going to take one block. I'm going to take one block as in the second image there, and I'm going to add it over there here. Okay. So earlier only one block was there as the weight. Now there are two blocks, but it is taken from the initial part. So the mass is kept constant. The mass is kept constant. The total mass is kept constant in the whole setup. There is no change in the setup's total mass because only the position has been changed. There is a replacing of the position within the same system, so there is no change in the mass. Okay. So if the mass is constant, what is the theory says? These two are direct proportion. So what I can observe here, when I increase the weight like this, that means the gravitational force, that is the force acting. I could see the trolley moves along the ramp at a high speed, And let's say another coin, another block I'm adding up with the same weight. Okay. So then three blocks will be there as the weight. What I could observe there, furthermore, it will be increasing the acceleration. Further, it will be running fast. Is that clear?
Yes, sir.
So, and another, like adding more and more blocks, and I'm going to check it out. But all at once you can't do. One by one you have to do. Then only you can see. So one you are taking, and again one you are taking. Not one after the other, you can't do like that. Once at a time. So from the very corner at this point, you can see there's a corner. From the end, you are going to keep the trolley, and you are going to add one block here. And you are checking what is the time taken. So how do you find out the acceleration? Starting velocity is 0. Okay, starting velocity is 0. And you are going to see how fast it comes to this other end. How fast it comes to the other end, you are going to check the time. And the second instance, you are going to add another block here. And again, you are keeping the trolley here with the remaining three blocks. And you are going to check what is the time taken for the object to come to the other end. Again, what do you do? Another block you are going to replace from here, and you are going to make it 3 at the mass hand. So you are going to check what is the time taken for complete one motion. Likewise, when you check more and more masses you add here over the mass angle, the weight will be high. When the weight is high over there, the gravitational force high over there, you can see it comes down, it slopes down very quickly. That means it is more faster. More faster means, what is the meaning of that? The velocity is increasing rapidly. It shows you it is accelerating. So it's confirming that since the mass is constant, force you increase, acceleration increases. You decrease the force, acceleration decreases. Did you understand that? So that is what the activity speaks about. So the theory is very clear, and the activities may be vary depending on the object. Different types of objects you can use. So imagine a football, you do have same football, you are going to use two types. A football you do have, you are going to hit it slowly. You are kicking on it slowly. Then it slowly moves, right? Next time the same football you're gonna keep at the same point, same person going to hit, same person gonna kick it. So the surface areas are not changing. Now second time bit faster. Okay, giving a high force. You are giving relatively a larger force on it. You can see more faster it moves. And again you do it third time. So further you increase the force. You can see it will be kicked bit faster move. So object is same. Mass is same. You increase the force, acceleration increases. You decrease the force, acceleration decreases. That is what the idea. So what is the formula we are going to build up? Formula we are going to build up using the relationship. What is the relationship? Force is directly proportional to acceleration. So this we can plot it on a graph. Okay. So you can see here acceleration taken on y-axis, force taken on the x-axis. Remember, any two factors directly proportional means any two factors directly proportional will be giving you a positive gradient and a constant gradient. Constant gradient. It won't be increasing, it won't be decreasing. A constant gradient will be given. So this is a constant gradient. It is not a curved gradient. It is a constant gradient. Data is continuous. Data is square. So constant gradient it is. So if you ask me, so why can't we take force to y-axis, acceleration to x-axis? Even you take like that. Even you take like that, same way it happens to be. Force you increase, acceleration increases. Okay. So this is the graph that we are drawing to show the relationship between F and E. Same like when you're gonna take the acceleration with mass. Now, can you remember I wrote this in two ways? Acceleration is directly proportional to 1 over m. Okay. Acceleration directly proportional to 1 over m. And again, I wrote another. Can you remember? Acceleration is now this alpha symbol I wrote in another way. What is the other way? I took it as 1 over alpha and m. 1 over alpha and m. So you see there, acceleration directly proportional to 1 over m, and these two factors if you are using on the graph, you can see acceleration in one side and the other side it is not just mass, it is 1 over m. Can you see that? Look at the difference. A as it is A and this is 1 over m, so you are taking 1 over m. And this is direct proportion, right? So it should be a positive gradient. It should be a positive gradient with 1 over m. And the same thing if you're gonna take it with m, what happens? Can you see that here? Can you see that here? Acceleration, you are going to take it with m. Acceleration, you are going to take it with m. So when you're going to take acceleration with m, that is 1 over alpha. 1 over alpha means inverse proportion. And does it mean that this is direct proportion? No, direct proportion with 1 over m. Direct proportion with 1 over m. Inverse proportion with m, both reverse. So when one is increasing, the other one will be decreasing. Okay. And the graph changes because of the way you are taking this factor. Earlier 1 over m, now you are taking m. Since you are taking m, you can see it's a curved graph coming down. It's a curve coming down that shows you when one is decreasing, the other one increases. When one factor, the y-axis when you are taking, okay. When one is decreasing, the other one increases. The other one increases. That is the idea given over there. Okay. So this comes for A and M. A and M. So let's take this also down. Right. Draw there. For the first graph, you have to take A is directly proportional to A. Okay. So when you're gonna take A and M, it is a positive gradient. Positive gradient. So it is acceleration. Acceleration is measured in meters per square second. Acceleration is measured in meters per square second. And force is measured in Newton. Direct proportion. Direct proportion. Okay. And what about the next one? If you're gonna take acceleration 1 over m, acceleration with 1 over m. Okay. So here acceleration is measured by meters per square second. And here mass is taken as 1 over m, right? 1 over m means it is not kilograms. It is kgm minus 1. You understand that? If it is mass, let me take here. You know, all the points I'm giving you because none of the points you should miss here. Acceleration is meters per square. I'm taking the mass here. Mass means kilogram. But here I'm taking 1 over m, right? That means 1 over kg. 1 over kg means kg minus 1. So you can see here. Here the graph, since it goes up with this direct proportion mark, it should be like this. But here, it is a relationship like this, right? 1 over alpha m, right? 1 over alpha m. So in this case, it should be a graph going down like this. Okay, is that clear? So this is how the graph happens to be. Clear? So three graphs I have given you, these two are the same. Okay, only the way, again and again I'm saying, only the way you are taking in. It's 1 over n, this is n. Okay, note it down please. Note it down please. Completely I'm giving you the theories. Okay, theory is already actual thing is you are already done with the theory related to the second loop. Okay, what I do here, okay, I'm not making it hard, but I'm making it all the possible ways open for you. Otherwise, I can just go to the next one. It's easy for me, actually. You have to understand that, right? So all the possible ways the questions could be given, the questions could be taken. That is what I'm taking up here. Okay, so better we miss nothing, right? Completely covering up, we go to the next one. So not to be hurried up. We're done, right? So So look at this. Now we are to the formula. It's actually F equals ma. What is the formula? F is equal to m into a. How is it built up? Acceleration is directly proportional to force. It is inversely proportional to mass. So when you're gonna take both of them, acceleration is directly proportional to force over m. Force over m. You're going to take both together. Both together we're gonna do. When you're gonna take both these factors together, A is directly proportional to F over m. A is directly proportional to F over m. So acceleration is directly proportional to force. Acceleration is directly proportional to 1 over m. So we're gonna take both together. Acceleration is directly proportional to F over m. F into 1 F over m. Okay. And what is the other one? So this m when you are taking here, F is directly proportional to m into a. F is directly proportional to m you are taking here, m into a. M into a. So this m into a and f, when you are going to take it in several experiments, you can see always there is a constant relationship given. So we are building up the formula. What is the formula here? F is equal to m into a, mass into acceleration. Mass into acceleration. Here the mass we measure in kilograms. Acceleration we measure in meters per square second. So the force is given in kilograms meters per square second. Kilograms meters per square second. But this is the fundamental unit. Remember, this is the fundamental unit. So this is taken as Newton. So you see, it is the fundamental unit of force, and this is the SI unit of force. So kilograms meters per square second, this comes in some short questions. Okay, kilograms meters per square seconds, that is the fundamental unit of force because of kg into ms2, and the SI unit is standard international unit is Newton. So this refers for 1 kilogram meters per square second is equal to 1 Newton. 1 Newton. This is the idea we are doing. 1 kilogram meters per square second is equal to 1 Newton. Okay, so that is the theory here. So could you write this down, please? We'll make it fast and we're gonna do some questions now. You know, in your paper, the exam papers, there are questions where they ask you to write the formula. Directly, you have to write this. They give you the terms also. What is the relationship between the force, mass, acceleration? They ask. So you have to write F is equal to m into a. Okay. And then the next question they will ask you to substitute it in a question. They will give some data. Properly you have to substitute and get into the data. That's it. Hope you are done. So now you see F is equal to M into A. Very simply we have to get into some questions. Okay. So remember in these types of question, mass is taken in kilograms. If it is given in grams, you have to convert it. And acceleration must be taken in meters per square seconds. Meters per square seconds. Right. Now, some questions are there. Okay. Where the mass and acceleration, both of them are directly given. Both of them are directly given. So you can apply F is equal to M into A. You can apply F is equal to M into A. Some questions are there. They don't give the acceleration. They don't give the acceleration. What they give is the data to find out acceleration. An object, it's having a mass M. Okay. It was at rest. Let's say the starting velocity. Just I'm giving starting velocity. There is a starting velocity U, and you are giving a force. You are giving a force, an unbalanced force. So what happened? It's moving. The same object M, and it is occupying a velocity V. Can you see that? What's happening here? Starting, it's having a velocity U, and you are giving a force. Unbalanced force is applied on this mass. So the same mass, it occupies another velocity, another speed. So there are two occasions here. One, either from a lower, less value, for a high value, it can increase. That means acceleration. So it can be accelerated. From rest, for an upper value, it can increase. Or else reverse. From an upper level, it can come for a lower level. Lower level. That means it can decrease. That is deceleration. Either it can increase or decrease. The time taken is t. Now the question is asking you, how much is the force applied? Then in this case, what are you supposed to do? First step, okay, you have to find out the acceleration. You want to find out the acceleration. How do you do that? Acceleration is equal to, so this is the step one. Acceleration is equal to final minus initial velocity dividing by the time taken. These three values are given, right? That will be given in the question. They will give how much is the starting velocity, final velocity, time taken. So using these, you have to find out the acceleration. This is the step one. Okay. And what is the step two? Step two. Now you know the acceleration rate. You will find out the acceleration rate. Thereafter, step two, if you want to find out. How to find out F now? F is equal to mass into acceleration. Okay. So what we discuss here, if the acceleration is not directly given, If the question gives you velocity change and the time, then using the velocity change and time, first you have to find out acceleration and then you can find out the force. So the answer is obtained in two steps. And those two at once also you can find. How do you find them at once? How do you find them at once? At once you are going to apply F is equal to M into A. Look at this. Okay, one method is this. The other method is F is equal to M into A. On the equation itself, at the place of A, you are going to apply this. V minus U over A. So you can find out. So two steps, both the steps at once. In this way also you can find out. Anyhow, the same answer you will get. Same answer you will get. So this is also a possible question. So the general idea to find out the answer, that the picture is what I'm giving. Take the note, please. So all what you have learned now, with this we are going to do some questions now. Done, right? So look into these questions. Let's do this. Write the question down. First question right there. What is the force required to give an acceleration of 5 ms minus 2 for an object of 10 kilograms? How do you find it? Now it's very easy. F is equal to M into A. F is equal to M into A. Formula is must. Formula is a must. Okay. Writing the formula, you have to substitute properly. When you are substituting also, guys, you know, mass and acceleration, that order you have to give. You can't write A first and M second. That is wrong. Substitution must be correct. In fact, that is mentioned usually in the marking scheme. Substitution in order, give 1 mark, they mention. If not, you are not getting marks. Okay. How much is the mass now? Mass is given. Yes. 10 kilograms. So 10, and it is not must to mention the units, but standard units, the values you have to apply. And acceleration 5 ms
5
minus,
meters.
yeah, 5 meters per
Five.
square. You can write 10 into 5, 50, and that is kg meters per square, right? Okay, per square seconds, right? So that kg, the fundamental unit, you don't want to show. Straight away, you can write it as 50 newtons. 50 newtons. That's the first question's answer. 10 into 5, 50. SI unit, you can apply for your answer. 50 newtons. Can I have the second question? A force applied on an object of 12 kg to move it on a straight linear way at an acceleration of 5. Calculate the force. So simply, how much is the force? F is equal to m into a. How much is the mass given? 12 kg. Acceleration given? 5 ms minus 2. 12 into 5, 60, and 60 newton. With the unit you have to give. And remember one more thing. If this is taken in kilograms, only then you can get the answer in newton. Because can you remember, I told you earlier, 1 newton is equal to 1 kilogram meters per square second. Okay. If you don't take this in kilogram and giving your answer in grams, then you can't end up the answer as newton without convert. Because 1 gram newton meters per square second cannot be equal to newton. Okay. It should be kilogram. So that we have to convert. Third question. I hope you are writing the questions quickly. Find out the answer to the third question. Then you have to apply the second formula. I mean the second step formula. You have to find out the acceleration and then you have to go for force. Or else both at once. Which is good for you, which is easy for you, you can apply. Get me the answer. That's the question number 3.
Mm. 400 newtons.
Is it? Let me check. Question number 3. Sharon, I hope you are writing answers. When a force is applied on an object of 25 kg, right? Let me write using the combined system method. F is equal to m into a. M into acceleration is equal to v minus u over t. So the mass is given, you can see it's 25 kg into, when it is applied, an object at rest moves at a velocity of 16 ms minus 1. It moves at a velocity of 16 ms minus 1. Okay. So starting velocity was at rest. Starting velocity was at rest. And it is moving at 16 ms minus 1. It acquires within 4 seconds. So final velocity is 16. Starting velocity is 0. Ms minus 1 divided by 4 seconds. Correct now? 16 final velocity. Initial velocity 0. 16 over 4 is 4. 16 over 4 it is 4. 4 into 25. 4 into 25 it is 100. 100 Newton is it? Is that 100 Newton you got the answer? Final velocity is 16. It was started from rest. Initial velocity 0. V minus u. 16 minus 0 is 16. 16 dividing by the time taken 4 seconds. 16 dividing by 4 is 4. 4 into 25, 100 newtons. 4 into 25, 100 newtons. Okay. That's the third question's answer. I hope it's clear. If you have a question, please ask. Get the fourth question now. Question number 4. You can get the answers now. Find the mass of an object which moves at 8 meters per square second when a force of 20 Newton is applied. So F is equal to m into A, and you want to find out the mass here. So subject m. Then A should be taken here down. It's very easy. F over A, correct? F over A. So m is equal to F over A. M is equal to F over A, right? So how much is F here now? F is given 20 Newton. Dividing by A is given 8 meters per square second. 20 over 8. How much is it? Is it 2.5? 2.5 kilograms, correct?
So I got 2.5.
2.5, right? Yes.
Yes.
So, Sharon, you have sent a message. So I have a question to the equation. F equals m into. What is U? Yeah. M is the mass and all the letters should be simple. No capital we are using except for force. Others are simple. Okay. So, mass is m. V is final velocity. U is initial velocity. V is final velocity. U its initial velocity. Okay. Fine. Get me the answer for the next question, number 5. A fourth question is answer 25, 2.5, right? Is it? Correct, it's 2.5. Number 5. Question number 5. When a force of 35 Newton is applied on a cuboid box, which is at rest, it acquires a velocity of 14 within 7 seconds. Find the mass of the box. Find the mass of the box. So, you can see here, this is also giving you the force, acceleration and all. I mean, acceleration you want to find it. And then you have to find out the mass. You want to find out the mass. So, what I do, let me write either this way I can write. So, I have to subject M, I have to subject M, or else what I do, I have to take in this way. First, I'll find out the acceleration. A equals V minus U over T. So, what is V here? Object at rest acquires 14. So 14 minus 0 meters per second dividing by 7 seconds. 7 seconds. So 14 dividing by 7, it's 2. 2 meters per square second, that is the acceleration. 2 meters per square second is the acceleration. Now I apply F is equal to m into A, and the question asks you to find out the mass. So mass is equal to F over A. How much is the force given? Force given 35 Newton. Dividing by acceleration, I found it 2. 35 over 2, it is 17.5. Mass is measured in kilograms. So 17.5 kilograms. 17.5 kilograms is my answer. Give me the answer of the question as well. So the sixth question. A cart of 50 kg, it is at rest, is pulled with a force of 600, moved for 20 seconds due to the force. What is the velocity? So you apply the force equation first. Force equal mass into acceleration. You want to find out the acceleration. So force over A. Okay? Because force and mass given, you want to find out the acceleration. Force is 600 Newton. Dividing by, how much is the mass? 50 kg. 60 over 5, how much? Is 12, right? So 12 ms minus 2 meters per square second. That is the acceleration. So why did I find out the acceleration? Because the question is asking you the final velocity. So if you want to find out the final velocity, as in this question, the final velocity v, right? Okay. So if you want to find out the final velocity, you must know the acceleration. So that I had to find out the acceleration first. So now I know the acceleration 60 over 5 means it's 12. So I'm applying A equals v minus u over t. A equals v minus u over t. So I want to find out v, right? When you subject v is equal to u plus at. I think I don't want to speak about that because we already did this theory and with questions earlier. So v equals u plus at. So what is the starting velocity here? Starting velocity was 0, right? And how much is the acceleration? 12. Into what is the time taken? 20 seconds. 20 seconds. So 12 into 20, 12 into 2, 24 with 0, 240 meters per second. Unit must be correct. This is not acceleration, velocity. So it should be meters per second, not meters per square second. Earlier I found acceleration, now it is the final velocity. Okay.
Okay, sir.
Right. I hope the questions are clear, right? Questions are clear. I'll forward you some more questions. Try it at home. Okay, try it at home. 6 questions we did. Some more questions are there. You have to try. And we have a small part, a small theory to finish it up. Okay. Then that the Newton's laws will be done. So let's have a look on that particular part. One small part we do have. Look at this. What is 1 Newton? Now all we learned about Newton, right? So what is this Newton? How to define 1 Newton? Now you see, this is the triangle that we are usually using for the equations. How to use this equation? Can you see? You want to find out A. If you want to find out A, how do you do that? You have to close A. You have to close A. Okay, correct? F equals m into A. F equals m into A. Formula goes like, so you are building up this triangle in this way. You know, F should be there here. M into A. You want to find out F, that means m into A. You want to find out M, F over A. You want to find out A, F over M. That is how we have used in our questions almost. So you see, A is equal to F over M. A is equal to F over M, F over M. And what is this 1 Newton? F is equal to M into A, right? Let's say an object you do have. You are having an object. The object's mass is 1 kilogram. The object's mass is 1 kilogram. You are giving a force. In order to accelerate by 1 meters per square second. Okay. 1 kilogram object. So the mass is 1 kg. Acceleration, definitely it must be equal to 1 meters per square second. To do so, on an object of 1 kilogram, how much is the force you have to apply? 1 into 1, 1 Newton. 1 Newton. So this is what we define as 1 Newton. So what is the force? What is the force needed to make a mass of 1 kg to be accelerated by 1 ms minus 2, 1 meter per square second? That is called 1 Newton. Okay, let's quickly take a note. Only that's the last part. Definition of 1 Newton, right there. Definition of 1 Newton. Definition of 1 Newton. Draw this diagram and write this down. Afterwards, mark it down. Okay, and also, yeah, draw this, and write this down, and then write down what is given on the screen. 1 Newton is the force needed to make a mass of 1 kilogram. Accelerate at 1 meter per second square. After writing that, you can draw this part. Hurry up. Are you done?
Sir,
Yes. I hope the result is clear. Any questions to ask? Sharing done, right?
last.
Fine. So please make sure I'll send you a paper. Okay, the rest of the questions, complete it at home. Okay. And the next part is about the weight, mass, that the relationship we have to build up. Okay. And then about the momentum, then that is the only part we have to speak in this first unit. Okay. So get prepared. Very soon we'll be having some sort of questions to be done online. Okay, very soon. Once it is set up, once it is scheduled up, I will inform you. So you have to get prepared. And I already told you, until then be tuned up with the online classroom. So still we haven't got any sort of stuffs done there. Okay, only the materials are being uploaded, and revision classes, some sort of revision sessions, and the videos will be uploading there, and online exams also will be having over there. Okay, fine. So see you then until the next class. Good night. Bye.
Good night, sir. Thank you, sir.